probability of A, and the probability of B given A is equal to the probability of B. These are two important notations that you need to know. So write those down. And also what you need to know for independent events, you need to know that the probability of A intersecting B, these are what is equal to the probability of A times the probability of B. And also you need to know that the probability of A intersecting B, this is the same as this one here, is equal. So these are basically the three notation, the three theorems that you need to know along with this extended one for independence. So you need to know that the probability of A intersecting B is the probability of A times the probability of B, and that the probability of A given B is equal to the probability of A, and that the probability of B given A is equal to the probability of B. Because they do not affect each other. Okay, let's look at this problem here. It said in a group of 100 people, 40 owns a cat, 25 owns a dog, and 15 owns a cat and a dog. Find the probability that a person chosen at random owns, for part A, owns a dog or a cat, B owns a dog or a cat but not both, C owns a dog given that he owns a cat, and D does not own a cat given that he owns a dog. Now, so we use, if you notice, we need to actually list our events or what we have so that you have no problem when you're solving. So we have that C is for those that owns a cat, D for those that owns a dog. So it said here the sample space, it said a group of 100 people. So NS is 100, and the number of people that owns a cat, party, and the number that owns a dog, 25, and those that owns both, 15, because it's the same here. 15 owns a cat and means intersection, or is union. So 15 owns a cat and a dog. So this is what we have there. Since it is out of 100, we can write the probability of these as a decimal, or we could use a fraction. So the probability of those that own a cat is 0.4. How do we get 0.4? It's 40 over 100. And those that own a dog will be 25 over 100, which is 0.25 or a quarter. And then those that own a cat and a dog, the probability of that is 0.15. We divide the 15 also by 100. So let me pause a minute there before we continue. Are there any questions? Are there any questions? Student, like I said, if I'm asking for, yes?
Are we going to use the probability of the conditional probability?
Yeah, but we're gonna be using that when we say like number C and number D, ones that are given. Now from the time we hear given that, that's conditional probability. So in this case, they're asking us, find the probability that a person true or rather owns a dog or a cat. So we need to use, based on the information being provided here, we also know that there are some people that own both a cat and a dog. So that we will be using the probability rules for combined event for part A. So we have the probability that dog union a cat because they want us, or means union. So the probability of dog or a cat owns a dog or a cat is equal to the probability of those that own a dog, the probability that those own a cat, and the probability that those that own both a dog and a cat. So you just substitute there. We know that the probability of those that own a dog is 0.25. The probability of those that own a cat is 40, which is 0.4. And the probability of those that own a dog and a cat is 0.15. So simplifying that, we obtain that the probability of those that own a dog or a cat is equal to 0.5. Now, this one you have to be very careful with. Part B owns a dog or a cat, but not both. So meaning the person owns a cat or a dog, but not both. So we need to go and look at our special results. For the probability, you have to do two things here. It said this is here, that the probability that a person own a cat intersecting, but own a cat, but not a dog. And then we have to find those that own a dog, but not a cat. It said here, owns a dog or a cat, but not both. So here, the probability that the person owns a cat, own a cat. So we have that the probability of C is equal to the probability of C intersecting D, plus the probability of C intersecting D complement. So here we are finding the probability that a person owns a cat, but not a dog. So the probability of owning a cat is 0.4. The probability of owning a cat and a dog is 0.15. Plus the probability of owning a cat, but not a dog. So when we find that now, the probability of C intersecting D complement, meaning that the person owns a cat, but not a dog, is equal to 0.4 minus 0.15. So the probability that the person owns a cat and not a dog is 0.25. Then we need to find it for the probability of those that own a dog. So the probability of owning a dog is equal to the probability of a dog and cat plus the probability of owning a dog but not a cat. Remember, in the first instance, the person owned a cat but not a dog. So the probability of D we have was 0.25. Probability of D intersecting C complement was 0.15. I mean, sorry, that's what we are looking for, D intersecting C. So when we plug in our value here, the probability of D is 0.25 is equal to probability of D intersecting C, which is the same as C intersecting D, which is 0.15, plus the probability of those that own a dog but not a cat. So our answer is 0.1. So to get our answer, this would have been the formula. So these are the conditions. If the person owns a cat, then the person doesn't own a dog. Or if the person owns a dog, then he doesn't own a cat. So we're going to add both of the probabilities together, 0.25 plus 0.1. And then our answer there will be 0.35. So that would be the probability of a person that do not own both. Like I said, owns a dog or a cat, but not both. Then part C, owns a dog. That's the condition. Given that owns a dog, given that he owns a cat. So I already told you that the person owns a cat. But now they want to know if that person owns a dog, given that he owns a cat. So that's conditional probability. So this is the probability that the person owns a dog, given that he owns a cat. So that would be the probability of D given C. So the probability of D given C is the probability of D intersecting C over the probability of C. And we know that the probability of C intersecting D, which is the same as D intersecting C, is 0.15, and the probability of C is 0.4. So the probability that the person owns a dog, given that the person owns a cat, will be 0.375. Then looking here, part B does not own a cat. Does not own a cat, given that he owns a dog. And down here, this means that the person owns a cat but not a dog. What we have here, which is 0.25. Right? They show that the person owns a cat but not a dog. So here we said that the person does not own a cat, given that the person owns a dog. This is the condition here. So that would be the probability of C complement intersecting D over the probability of D. It's noted the formula quite simple. When you look at this one, the probability of D is C, it's D intersects C over the probability of what is here, which is C. This is the probability of C complement given D. So that would be the probability of C complement intersecting D over the probability of D. So we have found the probability of a person that owns a dog but not a cat, or doesn't own a cat but owns a dog. That is 0.1. So how do we get this value? I told you we get that value here, that the person does not own a cat. Right here. So a person does not own a cat but owns a dog is 0.1. So we go back and we plug that there, and the probability of D was 0.25. So the probability that the person doesn't own a cat, but given that he owns a dog, will be 0.4. Are there any questions? Are there any questions?
No, sir.
Okay, let's look at this other problem here. A card is picked from a pack containing 52 plain cards. It is then replaced and a second card is picked. Find the probability that A, both cards are the 7 of diamonds. B, the first card is a heart and the second is a spade. C, one card is from a black suit and the other is from a red suit. And D, at least one card is a queen. So if you notice now, this will be selection with replacement, meaning then that you still have the opportunity to pick the same card that was drawn first as many times, because remember, it is being replaced back. Now, a card is picked from a pack containing 52 plain cards. It is then replaced and a second card is picked. Find the probability that both cards are the 7 of diamonds. So there we are looking at independent events, because each pick will be independent of each other, because you don't know what you will be selecting, even though that the object or the item has been replaced back. So we know that NS is 52, and we have the event A is a 7 of diamonds. So in order for us to get a 7 of diamonds, there's only one 7 of diamonds in that deck of cards. Do you agree?
Yes, sir.
But remember, the card is being replaced and picked back. So the probability, since you have used A here, the probability of getting a 7 of diamond at your first pick, this sub 1 means first pick, and because they are independent event, and those for this are getting another 7 of diamond for the second pick, that is equal to 1 over 52 times 1 over 52, because they're independent events. Remember, I told you the probability of A intersecting B is equal to the probability of A times the probability of B for independent events. And if it's extended, then you can extend the definition as well. So in this case here, we only have 1 7 of diamond, but however, selection was with replacement. So you still have another opportunity to abjure that 7 of diamonds. So the probability of A intersecting B, the probability of A sub 1 intersecting A sub 2. So join a 7 of diamond at the first pick and join a 7 of diamond at the second pick. So our answer there will be 1 over 2704. Now, the second part is telling us the first card is a heart and the second is a spade. So remember, the first card has to be a heart and the other one has to be a spade. So that is independent events as well, but with conditions. I won't say with conditions, but we won't be using condition problem. heart, and the first one has to be a heart, and the other one must be a spade. So that will be, we have that H is the heart and B represents spade. So the number of hearts that we have within a deck of other cards, like I told you, is 13. The number of spades is also 13. So the probability that we draw a heart first and then draw a spade second is like this. So that would be the probability of drawing a heart first and the probability of drawing a spade second. So 13 over 52 times 13 over 52, our answer would be 116. Any questions? Any questions?
Not as yet, sir.
Okay. So part C is saying one card is from a black suit and the other is from a red suit. So how many black suits do we have? How many black suits do we have?
6.
We have 2 black suits, spade and clubs, which give us a total of 26. And we have 2 red suits, hearts and diamonds. Putting both of them together will be 26. Guys, remember it's 13 of each. We have 13 spade, 13 clubs, 13 hearts, 13 diamonds. So from a black suit, we have 26. From a red suit, we have 26. So they want the probability, and if you have to be careful, so I put the event A, drawing a card from a black card, and drawing from a card from a red card. However, this could happen in 2 ways because it doesn't say you need to be drawing a black first, then a red. This doesn't give any conditions. So since we are dealing with probability, you could have drawn a black first because remember, and then a red second. Or you could have drawn a red first and then a black second. Those are the 2 possibilities. So that would be 26 over 52 times 26 over 52, because remember, these are multiplication, independent event, plus 26 over 52, 26 over 52. So we're gonna get a half times a half plus a half times a half. 1/4 plus 1/4, or answer be 2/4, which is a half. So that would be the probability of drawing a black suit and one from a black suit and one from a red suit. So the other part, at least one card is a queen, at least. One card is a queen. So what at least means now? At least one card is a queen. Remember, there are 2 cards that you need, but one of them has to be a queen. That's what this is telling you. So which means then there are 4 queens in an ordinary pack of cards. So you have 4 out of 52 to draw a queen. However, the remaining amount of cards would be 48. Because why? When you subtract 4 from 52, we get 48, which are not queens. So remember, the first card has to be, or what is it? The first have to be a queen, or you need to have a queen. Or at least one card is a queen, at least. Meaning then that you could have a queen and a queen as well. At least means one or more. So we have Q being a queen and Q sub 1, not a queen. So 4 and we have 48. Now, these are the different possibilities because they didn't say. You could draw a queen at your first pick and not a queen for a second pick. This is not a queen. Here, you can draw a queen at your first pick again, and here you could draw another queen. So this here is not a queen at your first pick, any other card, and then a queen. And the other pick, you could pick a queen and a queen. I said at least one queen. So these are the various possibilities. So remember, I have Q1 representing not a queen or others, and Q for queen. And this subscript means then that for the first pick, we pick a queen. Here, for the second pick, is not a queen. Here, the first pick is not a queen, and the second pick is a queen. And here, the first and second pick are queens. Those are independent events. So we're going to have 4 out of 52 times 48 out of 52. Then 48 out of 52 times 4 over 52 for this one. And then 4 over 52 times 4 over 52. 113, 12 13, 12 13, 113, 113, 113. So this would be 12 over 169 plus 12 over 169 plus 1 over 169. So we obtain 25 over 169, which is the probability of getting at least one queen. Are there any questions? These are independent events. Yeah, that's part D, so that's the last part. Now we have another one here. The probability that a person in a particular evening class is left-handed is 1/6 from a class of 50 women and 5 men. A person is chosen at random, assuming that left-handedness is independent of the sex of a person. Find the probability that the person chosen is a man or is left-handed. So what will we gonna be using there? What will we be using there? Students, are you hearing me?
Yes, sir.
Okay, so what will would we be using? Anybody?
Sir, wouldn't it be the one that you were using previous ago, sir?
The independent of events?
Yes, it says it's independent, but in some problem, we need to utilize both rules. In this case, we're gonna be using the rule for combined events. Because the person could be a male and is left-handed, or the person could be a female and is left-handed. So here they're asking, find the probability that person is a man, which is a male, is left-handed. So we could choose a man, and then we could choose a man that is left-handed. So that will be the probability rule. So let L be left-handed, W for women, and N for men. So the number of women is 15, the number of men is 5, and the sample space is 20. Because remember, when we add 15 and 5, that's 20. And the probability they gave that left-handed is 1/6. That was given in the problem here. So they want us to find that the probability that the person chosen is a male, a man, or means union left-handed. So that should be equal to the probability that it's a man plus the probability that the person is left-handed minus the probability that he is a man who is left-handed. That's two, those there. So we plug in, if you notice for the intersection, I use the independent event. So we have 5/20 plus 1/6. And then for male, it's 5/20, the 5/1/6. Because this is independent event. So we get 5/20 plus 1/6 over 1/24. So the probability that it's a man or left-handed is equal to 3/8. A bag contains 4 red counters and 6 black counters. A counter is picked at random from the bag and not replaced. And not replaced. A second counter is then picked. Find the probability that the second counter is red, given that the first counter is red. B, both counters are red. C, the counters are of different colors. So, how do we interpret this question here? What is one thing that you must bear in mind when solving this problem?
Sir, wouldn't it be like a combined event, sir?
Yeah, we're gonna be looking at conditional event and combined events and those things. But this one, both counters are red. Independent event, I wouldn't say combined, but independent events and conditional events. But what would be the major thing we need to bear in mind here?
Like the word given that would be conditional event.
Yeah.
Conditional probability, I mean.
Yeah, conditional probability, or it could be event too, doesn't matter. But looking at the problem we read, and there is something very, very vital that they mentioned.
Sir, in A, because in A we know that we have 6 black counters, you know. And I mean in the bag contains 4 red counters and 6 black counters. But then
Yes.
question A, it wants the statement is saying that the second counter is red, given that the first counter is red. So they want the second counter to contain a red.
Yes. But the one thing that I was thinking that is it said here, it's selection, it is not replaced.
Yes, sir.
That's the thing that you need to bear in mind. Because which means then if it's not replaced, meaning then that the possibility space will be decreasing. So the possibility space will be decreasing as we go along. Because remember, you are selecting and it is not replaced back. Are you getting the picture too? Well, everything else that everybody mentioned is also right, but that is one thing that you must bear in mind. So the second counter is red, given that the first counter is red. So R, red counters, B, black counters. Excuse. The number of red we have is 4, number of black is 6, sample space is 10, but remember it won't be remaining that way. So now this is telling us that your second counter will be red given that the first you have selected is red. So that will be the probability that the second counter is red and the first one is red over the probability that it is red. The first one is red. So it's independent event. How do we get 3/9? Because 3/9 would have been the second counter. Remember, we have 4 red counters. But if the first one is already red, which means then that we only have 3 red counters remaining. So that's a 3/9 now, which you will be drawing the second pick. Because remember, if the first one is red, that is out. It is not replaced. So you will have only 3 more red, so that will be 3/9. Everybody got the picture? Everybody got the picture there?
Yes, sir.
Yes, sir.
And here for the red counter, drawing a red counter first, you have 4 of them, so it's going to be 4 out of the total, which is 10. Over 10. Now, remember, like I had told you before, the probability of A given B for independent event is the same as the probability of A. So in this case, I mean the same as the probability of A. So this is saying here that if you notice, these two will cancel out, and we're gonna get 3/9, which is 1/3. And this here is the probability of R1. So we could say here that the probability of R2 given R1, because independent, is equals to the probability of R1. And the probability of R1 is 4/10, is equals to R2. So the probability of R2 will be 3/9, which is 1/3. Looking at that formula that I gave, remember that formula that I mentioned to you? For independent event, the probability of A given B is equal to the probability of A, and the probability of B given A is the probability of B. So the probability of R2 given R1 is the probability of R2. And the probability of R2 is 3/9, and it is 1/3. So you could have used that easier formula rather than using, but I use the conditional formula here so that you know how to use it. But if you can spot it very easy, then it shouldn't be a problem. Both counters are red. So what will that be? Both counters are red. Find the probability that both counters are red. So it's going to be that the probability that the first pick is a red and the second one will be red. But what should you consider here again? What should we consider here?
That they are not being replaced.
Okay, it is not being replaced. So selecting the first red counter would be 4/10, and then selecting the second one will be 3/9. And so our answer will be 2/15.
Sir, but I do not understand how you get get 3/9.
Because it's 2. It said here. Okay, let me show you again here. Both counters are red. It's two sections. It said here that a counter is picked at random from the bag and not replaced. A second counter is then picked. So it's two selections. Now, if it is not replaced, then picking the first red counter because it's two of them. Because it's two pick you're doing. Picking the first one will be 4 out of 10. Now, remember you have taken out one, so the sample space will be 9 and only 3 more red. So to pick a second red counter, it will be 3 out of 9. Is that clear?
Yes, sir. Thank you.
Okay, so that will be 2/15 then. Any questions? If there is no question, then our class has come to an end. It's now 8:59. Are there any questions? I need to send this work to you. Time is going, and I have to give you some assessment too. I'm a bit behind, but when I start giving work, then we're gonna see what will happen. Any question? Okay, well,
Yes, sir.
well, enjoy the rest of the day, and I will be sending you the work so that you can go over it and practice and
Yes, sir.
see
Thank you.
how those things close. Okay, so you don't need to worry about that. And we need to upload these today. Later today, I will do that. So enjoy the rest of the day. And
Okay,
be
sir.
safe.
Thank you, sir. Same.
Okay. Take care, everybody.
Same, sir. Bye.
Okay, bye.